Welcome guys to the technical teardown of off-road scooter fabrication, starting with sorting out the off-road tires. They feature large treads and cast alloy rims for grip. The expert is using a caliper to accurately measure the diameter tolerance. Selecting the steel tubes, flanges, and bearings requires high precision. He checks the play of the bearings before pressing them into the steel sleeves. The press-fit principle is applied here so the bearing sits tightly inside the cylindrical tube. He then selects the washers and standard brake components for the braking system, marking the positioning points on the rim, in preparation for drilling and installing the connection flange. The steel flange is perfectly aligned to the center of the wheel hub. Proceeding with TIG welding using argon shielding gas to secure the 4 high-strength bearing bolts. The TIG weld provides deep penetration and is extremely clean, leaving no welding slag. A thick steel tube is then placed into the vise to press the hub bearings. The pressing force from the mechanical vise helps the bearing go in smoothly, without deforming the bearing races. The flange joint, whose retaining bolts were just welded, is tacked directly to the axle tube assembly. The mechanic welds a thick bead all the way around to rigidly lock the central drive structure. Moving to the drill press, positioning holes are drilled on the flange to mount the brake disc. The curling metal shavings show that the HSS drill bit is cutting very smoothly. Using a threading tap attached to a hand drill to create internal threads for the newly drilled holes. Adding a small steel cup to protect the axle and increase the stability of the hub assembly. Continuing with precise TIG welding operations. Now comes the step of tightening the bolts to secure the steel brake disc. Even tightening torque prevents the brake disc from warping, ensuring hydraulic braking performance later on. Pressing another bearing into the bushing using a custom-made, specialized pressing tool. Assembling the entire brake disc and axle assembly into the core of the wheel rim. The fit is perfect. Measuring the tire diameter to calculate the suspension, travel, and ground clearance. Starting fabrication of the rear swing arm by cutting V-shaped notches on galvanized steel square tubing, folding it, and tack welding to shape the swing arm. The angled swing arm is calculated to withstand torsional forces, using an angle grinder to grind down and flatten the welds, improving aesthetics. Continuing to work on the main cylindrical tube of the vehicle, pressing 2 bearings at both ends using a vise to serve as the front fork pivot. A solid steel axle pin is pushed through to check the smoothness of the bearings, using a tri-square to ensure perfect perpendicularity when aligning the cylindrical tube perfectly square with the swing arm. Proceeding to fully weld the connection point. Perpendicularity is crucial to prevent the vehicle from wobbling. Trial fitting the bent steel tube that serves as the load-bearing subframe for the seat and shock absorber. Now, sliding the brake disc hub assembly onto the main swing arm axle, locking it in place with a thick washer and a large nut. This single-sided swing arm design has a Ducati-inspired vibe. Mounting the hydraulic brake caliper onto the disc and welding the caliper bracket directly to the swing arm. This ensures linear braking forces dissipate straight into the rigid frame structure. Back to the drill press to create assembly holes for the front wheel axle flange. Continuing the familiar process, using a vise to press bearings into the front axle bushing. The mechanical structure is built by stacking and welding steel plates to create the necessary thickness and setback. The TIG welding torch continues its precise rhythm, locking the flange to the bearing tube, grinding the weld surface flat to create an absolutely perfectly flat surface before mounting the front brake disc. Countersunk hex screws are used to tightly secure the brake disc, capable of withstanding high reverse torque. Repeating the preparation of the spacer tube and bearings for the rear chain sprocket drive system. A thick threaded steel pin is inserted through the tube. This will be the engine's main power transmission shaft. Pressing this axle support flange assembly into a single solid unit and locking it with a lock nut, preparing to assemble the front wheel onto the suspension system. Inserting the axle into the center of the front wheel, starting to securely tighten the positioning nuts. Using a wrench to tighten both sides of the axle, ensuring the wheel spins smoothly. Using a tape measure, taking measurements again to prepare for building the main frame. Moving on to the mechanical tube bender. The steel tube is bent into a U-shape. Decisive actions create a solid rear section to accommodate the rear suspension. Weld the hinge joints onto square steel tubing to create a pivot joint for the swing arm. Attach the steel pins to the pivots, Check the coaxial alignment of the frame hinge and proceed to assemble the square steel bars into a rectangular protective frame. TIG weld the corners of the rectangular frame to ensure perfect right angles for chassis strength. Use an angle grinder to clean the weld slag, smoothing out any sharp edges. Place the U-shaped frame onto the hinge mount. Determine the appropriate tilt angle and fully weld it. This structure creates a strong, solid rear frame to bear the rider's weight. Prepare 2 dual spring shock absorbers and mark lines on a flat steel billet. Drill holes to fabricate the shock mounts, connecting the shocks to the U-shaped frame. Temporarily bolt the steel mounts to the shock heads to accurately determine the welding position. Weld the shock mounts to the frame. The dual rear suspension system is now formed. Measure a 45-degree angle on the main square steel bar and use a grinder to bevel the edges. Join the beveled edges together to form a V shape. This is the vehicle's flexible structure. Mark and drill holes to attach the brackets for the secondary hinge connecting to the central frame system. Weld these mounting brackets to the tail of the V-frame. Prepare to connect the front and rear halves using a square to check the alignment before welding the central hinge pin. To assemble the front half of the frame to the rear, install an additional blue monoshock. This central shock helps eliminate chassis folding vibrations. Fully weld the shock's mounting points. The frame now features a central shock absorbing joint. Stand it upright to check the compression travel, then assemble the rear swing arm, tire, and brake to the tail hinge axle. Tighten the swing arm axle nut to ensure the rear wheel moves up and down smoothly with the dual springs. Tack weld the brake caliper mount to keep the hydraulic caliper from spinning when braking. The steering neck tube and handlebars are welded onto the front of the V-frame. The triple tree structure acts as the vehicle's center, helping to optimize the steering angle and withstand diagonal stress. Mount the front tire onto the steering fork and insert the bolts to secure the wheel to the central flange. Use a wrench to evenly tighten the rim bolts, creating dynamic balance during operation. With both wheels fully assembled, place the vehicle on the floor to check its overall balance. Place thin steel sheets onto the frame to serve as floorboards. For the feet, drill holes and use self-drilling screws to securely fasten the floorboards to the rectangular steel tubing. Another sheet metal panel is mounted onto the U-frame to act as a rear mudguard. Weld the seat mount onto the horizontal frame bar. Insert the seat post and tighten the wing nut. Install the kickstand under the floorboard. TIG weld the kickstand mount and attach the tension spring to help the kickstand automatically fold away neatly while moving. Bring the miniature 4-stroke gasoline engine with a displacement of about 49 cc to the workbench. Measure the dimensions of the engine block base. Prepare a thick steel plate to serve as the engine mounting base. Use a ruler and pen to mark the centers of the bolt holes. Prepare an appropriate drill bit. Move the base plate to the drill press and precisely drill the anti-vibration bolt holes, and assemble the engine onto the base using hex bolts and rubber damping pads. Securely tighten the screws to ensure the engine block doesn't shift when operating at high RPMs. Attach additional steel L brackets to reinforce the rigidity of the entire engine assembly. Remove the clutch gearbox cover to access the engine's output drive sprocket. Use a cordless drill to quickly remove the screws, fully revealing the small sprocket. Mark the center on a large sprocket in preparation for precision machining. Drill the positioning bolt holes. The flying aluminum chips show the material is quite hard. Use a hole saw to cut a hole to widen the center of the sprocket to fit the rotating shaft. Fabricate a bay.
Custom sprocket hub from a steel washer and zinc bushing. TIG weld the seams to lock the sprocket hub in place. Then attach the large sprocket and tighten the securing nuts. Assemble the entire large sprocket unit onto the front wheel axle, turning it into the drive wheel. You'll use a socket wrench to tighten the axle nut, ensuring maximum power transmission without slipping. Place the engine mount base onto the front suspension system. To use a wood block as a spacer to adjust the gap before TIG welding, tack weld the engine unit onto the steering fork. With the front drive structure complete, install the chain, connecting the engine's small sprocket to the large sprocket on the front wheel to transmit torque. Install an automatic chain tensioner with a plastic roller to keep the chain tight and stable. Moving on to the handlebars.
And install a pair of angular sports rear view mirrors onto the handlebars. Route the hydraulic brake line and connect the brake caliper using a specialized banjo bolt. Open the handbrake fluid reservoir cap, preparing to fill it with standard hydraulic fluid. Pump brake fluid into the system. Squeeze and release the brake lever to bleed out air bubbles, ensuring proper brake pressure. Seal the reservoir cap tightly. Clean up thoroughly to prevent fluid from corroding the surrounding metal. Connect the throttle cable from handlebars directly to the engine's carburetor throttle valve. Adjust the throttle cable travel for the best response, without binding when turning. Open the fuel tank cap. Refuel by pouring a gas-oil mixture into the engine's fuel tank. The pale yellow fuel flows into the tank. Tighten the cap, ready for the first start. Insert the key into the ignition, and turn on the power switch to activate the CDI ignition system. Pull the manual starter cord firmly. The engine roars to life, and the front wheel spins rapidly from centrifugal force. Testing the engine RPM. The sprockets and chain operate smoothly, with no chain slippage or derailment. Turn off the engine using the key. The scooter is finished with a striking yellow and red paint job. Preparing for a test ride. The vehicle speeds along the asphalt road. The front-wheel drive design pulls the scooter very smoothly. The suspension system, with a central monoshock and dual rear shocks, absorbs speed bumps incredibly smoothly. Cornering at fairly high speeds, the frame's central hinge helps maintain excellent balance. The off-road tires provide great traction. The chassis perfectly handles the weight of an adult. A low-angle shot shows that front-end vibrations are significantly dampened. Test riding on bumpier terrain, the shocks rhythmically absorb all heavy impacts. Torque from the small gas engine is still enough for impressive acceleration on straightaways. A unique DIY design, combining precision mechanics and fantastic engineering creativity. The test ride is a complete success. I'll see you guys in the next fabrication project.